Alright, hi, I'm Bijan. I'm the programming CDT captain for more Robotics. And today I'm going to be talking about basics of programming in the F.I.R.S.T Robotics competition. There are three programming languages that teams can choose from. The first is LabVIEW, which is basically a picture-based language. Just drag and drop what you want to make the robot go. The second is Java, which is a text-based language, so you type out the code you want. And the third, which is what we use, is C++. It is very similar to Java, but it's faster, slightly faster. Go ahead. So the base of the program looks like this. It's separated into basically four parts. It's something called robot demo, which is called a constructor. It's basically where you let's create like all the stuff you need for the program to work. Like for example of last year's robot, the Catapult, the intake, the drivetrain, stuff like that. The second portion is where you put the autonomous code. The third is where you put the teleop code. The fourth is where you put the code you want to run when the robot is disabled, and the fourth is where like test code you want to run. But we don't really use that. We think it's just simpler to put the test code in operator control and test it there, and then fix it, and then put it into normal robot code. Go ahead. Alright, so I want to take a note that the rest of the code examples will be based off the Catapult in our 2014 robot. And if you don't know how that worked, it basically there's a hook that held the Catapult down, and then to shoot, the hook was released, the Catapult would fly up, and after that, a belt on a winch would pull the Catapult down until it hooked again, and then the winch would unwind the belt so that there's enough slack for the Catapult to go and shoot. So this is how you represent a part of the robot in the code. So for this example, we're going to create a virtual representation of a talon, which is a component used to determine the speed of the motor. So the first thing is in this example, talon is the type of thing you want to represent. The second part, in this example, is loading motor, is basically what you want to call that thing you're representing. And then the third part, right here, it's new talon. It's the part that actually creates the virtual representation of the object. And that one there is not very significant. It just means what port the talon will be plugged into. Okay, a very important part of programming, keeping the program organized, is something called classes. A class is a virtual representation of a real-world object. It's a great way to organize codes and keep things separate to themselves. And a class contains what an object has and what it does. So, an example of this is the Catapult, like I talked about. What it has is a motor to bring the Catapult down, two limit switches to detect if the Catapult is down, a motor to release the Catapult, and a limit switch to detect if the Catapult was released. And what it does is simple, it just shoots, reloads, and stops. And this is an example of a Catapult. You see up there below the word private, we basically declare the loading, the two motors, the motor controllers, talons, and the limit switches. And then down here we have like shooting, loading, and stopping. And this is basically a stripped down version of a file, because classes are broken up into two parts. The first part is basically saying, okay, here's what we're going to have. The second part is the actual code for it. This part is a stripped down version that says, okay, this is what is going to be in this class. Yep. And another thing we use that's very important is called a state machine. A state machine is a piece of code that breaks down complex actions into multiple steps. It performs one step at a time until a condition is met, and then it moves on to the next step. So here's an example of the function the code to load a Catapult. So up there it says, okay, if we're in the state of pulling the Catapult back, move the loading motor backwards to pull it back, and then check if the limit switches are pressed, or if a safety timer expired. Then clean up, and then move on to the step to release tension, where it moves the winch and the belt backwards. And then when that finished, when the timer is saying, okay, you're done, expires, stop the motor, and then go into an idle state, which means we're basically done for now. And so more information, if you want to learn C++, would be cprogramming.com or c++.com. It has really good tutorials on how to learn C++. And if you know Java, that's very similar to C++. It won't be that big of a jump for you guys. And then if you want to look and see our past robot code, that's available at github.com/robotics1714. So, questions.